I realized that our potato tax example would give us a nice opportunity to practice calculating elasticities with the point slope method, and I know how much you guys love doing that, or are going to love doing that in the course of preparing for the exam for this unit. So let's get started. Remember, we found that the buyers paid a very large percentage of the tax, the $3.50 tax on potatoes in my previous example, and the sellers paid very little. And remember, I told you that it's the absolute values of the elasticities in question that determine how that tax is shared, not whether you collect it from buyers or sellers. It's very counterintuitive, but yet very true in economics. Anyway, by that result, we expect that the price elasticity of demand in absolute value is much smaller than the price elasticity of supply. And we can sort of see that by the shapes of these demand and supply curves. Notice the demand curve is steep relative to this very flat supply curve. But let's go one step further and get some practice calculating elasticities while we're at it to make double sure, as I'm sure all of you are interested in doing. All right, well, let's remember the point slope formula. Oh, for some reason my graph is moving around instead of my writing. Sometimes that happens as the heel of my hand hits the screen instead of the tip of my pen. All right, so the elasticity of demand, remember the point slope formula, is 1 over the slope times price over quantity. All right, and that turns out to be, let's see, the slope of this demand curve, we can just take rise over run for the slope. That's $30 over 500 million bushels, just looking at the rise from 0 to 30 and the run from 0 to 500 million. And we want it 1 over that, so we're going to take 500 million divided by $30 and see what that looks like. So let's go back to my pen. 1 over the slope should be, of the demand curve, should be 500 million over 500 million bushels over 30, and the units there are dollars per bushel. And then we're going to multiply that by the price. The price is, originally we're just looking at the elasticity at this original point. And so the price was $6 per bushel, and the quantity sold was 400 million bushels. Now, before I start calculating, I'm going to just cancel everything I can cancel to turn this into as easy a calculation as I can. First off, notice the units cancel. Elasticity is a unit-free measure. So over bushel in the numerator, 1 over bushels in the numerator cancels with 1 over bushels in the denominator. Also, million bushels in the numerator. The 1 million over 1 million is 1. Bushel over bushel is 1. We can treat these units like algebraic entities for this purpose. Dollars cancel out. All right, well, it's getting much simpler. 100 divided by 100 is also 1. So this 400 becomes 4, and that 500 becomes 5. What else? Well, I know that 6 over 30 is the same as 1 over 5. So that's making it simpler. Now I have 5 over 5, so that cancels. So now I'm left. I don't have to do any calculations. This was a negative number. My elasticity of demand is negative 1 over 4. All right. So that's it. I'm going to compare it in absolute value. So let's just see what the absolute value is. It's, of course, 1 over 4. All right, let's do the same for elasticity of supply. I'm just going to do it over here on the left. I'll do the elasticity and supply in blue just to differentiate it. I'm talking and writing again. Bad, Phil. It's like walk. You should see me try to walk and chew gum at the same time. All right, elasticity of supply. Same logic. Now the slope, we're going to just measure it from this point to this point because that's the easiest segment of that line. You just why do it the hard way? And the formula is again 1 over the slope, only now we're doing the slope of the supply curve times P over Q. All right, well, let's figure out the slope of the supply curve is rise over run. That's $4 is the rise from $2 to $6, and then that's this one, and then the run is from 0 to 400 million. So if I want to take the reciprocal of that, I have 400 million bushels per year. I'm going to forget the year just because I'm sloppy. Over $4 per bushel. And then I'm multiplying that by the price level and the quantity level that where we're evaluating elasticity. And that's going to be, well, it's the same as before. $6 is the price per bushel over 400 million bushels. Well, I'm going to get a lot of things to cancel out here. Notice the units all cancel out. The millions still cancel out. Let's see, 400 over 400 is 1. So I'm left with positive 6 over 4. Positive 6 in the numerator is the only thing left that hasn't canceled over 4. So the elasticity of supply is positive 1.5. So we compare those two things, we notice that elasticity of 1.5 is much bigger than the elasticity of 0.25 or 1/4. So again, we verified that the party with the less elastic function pays more of the tax. So buyers can't switch away from this market. Sellers can. Buyers thus pay a much higher share of the tax on potatoes.